this is the solution to challenge 5. Remember that we were offering you two decision situations. In the first one, you had to choose between going for sure to for a weekend, for 2 days, to Pantin, the surfing paradise, and the other choice in that case was to enter in a lottery in which with probability 0.5, so say tossing a coin and getting heads, you would spend there 1 week, and if tails comes, you would remain in your place. In the second one, you again had two choices. The first one, the lottery was giving you with probability 0.1 2 days, a weekend there, and with probability 0.9 nothing. And the other alternative that you could choose refer to getting with probability 0.05, sorry, a week there, and with probability 0.95 nothing. So if we do the analysis through expected utility, for example, the expected utility of this decision, which is reflected there, would be the probability 0.5 times the utility of 7, and the probability of 0.5 times the utility of 0, okay, which is there. Similarly, the expected utility here would be the probability, which is 1, times the utility of 2, which is there. You can assume that the utility of the best price in this case is 1, U of 7 is 1, and the utility of the worst price here is, which is 0, is 0. So the expected utility of this is 0.5, and the expected utility of this decision is U2. And depending on whether this number is bigger or smaller than 0.5, you would choose this alternative in case U2 is bigger, and you would choose this one in case 0.5 is bigger than U2. Now, if you make the analysis for this decision tree, you get that the expected utility of this decision is are the probabilities times the utility, so it's 0.05 times utility of 7 plus 0.95 times the utility of 0. And in this case, the expected utility is this probability times utility of 2 plus 0.9 the utility of 0, which is reflected there. Again, if you assume that we keep on assuming that the utility of the best price is 1 and the utility of the worst price is 0, so we get this simplification, and then multiplying by 10, you get the same kind of relation between these. So if in this case this utility was bigger than 0.5, meaning that you prefer this one to this one, then this number keeps on being bigger than 0.5, and consequently you should prefer this lottery to this lottery. So there should be a consistency between this decision, this choice here, and this choice here, and vice versa. Several of you have replied that you were preferring this one in this lottery because you had a sure price here, which was interesting. But in this case, you were preferring this one, and the kind of rationale that you could expect is that the probabilities are quite close now and quite small, and this price is much better than this one. So somehow this compensates, and this inconsistency in the decision is incompatible with the expected utility theory that we have sketched in video number 5.